Although part C is not a related rates problem, I think it's good to just review what's going on because it is kind of tricky. The area in square feet of the horizontal cross section at height h is modeled by this function f. So what they're really saying is, here's the area, and this area is determined by this function f. Based on this model, find the volume of the tank, indicating units of measure, and as we go up, our height changes. So if we were going to sum up all of these various areas, we can think that our thickness would be dH. And so volume is always area times thickness. In our case, our volume will be the area function, 50.3 over e to the 0.2h plus h times dH. That's our thickness. And we're going to go from 0 to 10 because the tank has a height of 10. And we'd use our Math 9 to figure this out. One thing to think about, when you're using Math 9, the only variable it's going to be easy to use is x, and that's fine. As long as you're consistent, your calculator doesn't know any difference. We've got 101.325, and our units would be, if our area was in square feet and our height was in feet, then our units would be in cubic feet because we wanted volume. That's part C, which is not related rates. Now take a read at part D. So as we think about part D, we are asked, using the model from part C, find the rate at which the volume of water is changing with respect to time when the height is 5 feet. Indicate units of measure. And so this was our model to calculate volume. And so as we think about taking the derivative of this integral, and notice this is at any time, at any height y. That's what that really represents. We're just using a dummy variable so that the limit of integration is different than the h. And so we're going to take the derivative of both sides. We're going to take the derivative with respect to t of the integral from 0 to y of 50.3 e to the 0.2h plus h times dh. And as we do, the fundamental theorem of calculus would tell us that the derivative and the integral undo each other. And so what we have is the original function 50.3 over e to the 0.2, and our value y is plugged in for h. However, like always, we must multiply by the derivative of the limit that is not a constant. So I'm going to take all of this and multiply by dy dt. And that is what was given here as the height is increasing at a rate of 0.26 feet per minute. That's exactly what dy dt would be, thinking about units and everything else. This is 0.26 feet per minute. And our y is 5 feet. So every time we have a y, we're going to plug in the instant of 5 feet. And therefore our dv dt is equal to 50.3 over e to the 0.2 times 5 plus 5 times that dy dt value of 0.26. And we're going to get an answer of 1.694, remembering to round to 3 decimal places always. Now we go back and look. Oh, indicate units of measure. So we were asked for a change in volume, and our volume was feet cubed, and our time is minutes. So that's what we would write for our units.